Hello and welcome to What on Earth For. How often do you find yourself asking the question, what on earth is hydrofracturing? All the time, am I right? Never fear, this episode is going to answer just that question. As a polar scientist, I spend a lot of time thinking about ice shelves on the Antarctic Peninsula. Ice shelves are these floating platforms of ice which are formed when ice flowing off the steep Antarctic continent hits the sea and spreads out to form these floating tongues. These are really important for restraining all of the glaciers that flow down off the continent, and in fact, if you remove the ice shelves, it's like taking the plug out in the sink. When those ice shelves collapse, and they do so in spectacular fashion, we saw that in 1995 with the collapse of Larsen A, and then again in 2003 with the collapse of Larsen B. When these collapse, it can cause those glaciers to accelerate quite rapidly. Now, this process of ice shelf collapse is due to something called hydrofracturing, which is literally cracking due to the pressure of water. Just to give you a little bit of context, ice shelves are not just chunks of completely frozen ice. They've actually got many different layers within them. At the top, we've got a layer of freshly fallen snow, and right at the bottom, we've got completely densified ice. Now, somewhere in the middle, we've got something called firn, which is not quite snow, but it's not quite ice either. This firn layer is really important in the Antarctic Peninsula, which is a relatively warm region of Antarctica. We get lots of surface melting in the summer, so that surface meltwater is able to trickle down into that firn layer and refreeze. The thing is that once that refreezing occurs, that firn layer is no longer able to act as a buffer, and in fact it becomes quite brittle and susceptible to fracturing. And this is what happens during the process of hydrofracturing, where meltwater that forms on the surface has nowhere to go except into existing cracks, rifts and crevasses. Now, as I'm sure you all know, water is pretty heavy, and as water fills up these crevasses and these cracks, it exerts pressure on those cracks. Once it reaches this critical threshold, the magical 90%, then the pressure exerted on the tip of that crack is enough to cause it to propagate. Those cracks widen and they deepen. If this happens enough and they keep filling up, then those cracks can actually reach all the way to the bottom of the ice shelf. And this is when we see these very dramatic splintering events that cause the collapse entirely of complete ice shelves.